Pluto had issues from the day it was discovered. Many of them were swept under the rug because it was just nice to have discovered a planet in the 20th century. There was a strong urge to keep Pluto alive. In this thrilling video, we delve into a revelation that could change our understanding of the outer reaches of our solar system. Everybody wonders about Pluto. I mean, it's just an extraordinary world. There are regions, dark terrain, light terrain, nitrogen, so why haven't we heard from the aliens? Elon Musk, the visionary behind SpaceX, has made a startling discovery that uncovers what NASA has allegedly been keeping secret about Pluto. Do you become a multiplanet civilization or not? If you don't, it's simply a matter of time before something happens on your planet that causes us to die out. What lies hidden in this distant, icy world? Pluto had it coming from the beginning. Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet. Every innovation in modern technology opens another chapter in the story of our space exploration adventures. Looking back, we have no doubt made giant strides forward in our space missions since Neil Armstrong set foot on the moon. Still, the vast cosmos and our inability to fully unravel all the mysteries of the universe is a constant reminder that there is so much we need to learn. This is where NASA's innovative projects and instruments come in. The James Webb Space Telescope, JWST, was launched to unveil distant worlds and peek into the origin of the universe. Most importantly, this equipment is a monumental extension of NASA's previous missions. The excitement of understanding cosmic mysteries of the past is an epic adventure. We are still curious about the Big Bang, the formation of our solar system, and, more importantly, we strive to find a definite answer to the possibility of alien life outside our home planet, Earth. Could our knowledge of the solar system evolve into a new field of study? Will the new information gathered through the James Webb Telescope force us to reconsider our fundamental views of the universe? These questions prompt a review of our current knowledge, especially our understanding and classification of Pluto as a dwarf planet. Thanks to the New Horizons mission and its groundbreaking discoveries, we've been able to learn much more about Pluto. The billion-dollar investment has revolutionized NASA's efforts and expanded our understanding of the icy planet. Before the New Horizons mission, our knowledge of Pluto's surface was minimal. The most detailed image we had, taken by the Hubble Space Telescope in 2002, revealed a mysterious mix of colors on Pluto's surface. The colors included shades of orange, white, and black, along with a bright spot that caught scientists' attention. Given the few details offered by the Hubble Space Telescope, investigating Pluto was similar to trying to solve a puzzle with only a few jumbled pieces. Then, the James Webb Space Telescope appeared on the scene. It journeyed into Pluto's orbit, taking several stunning pictures that gave scientists a whole new understanding of that planet. The telescope caught a glimpse of Pluto's surface, the craters, the plains, and the mountain peaks. All of the planet's features were present in the finest details, showing traces of its geological history. The scene was like being granted a VIP backstage pass to a magic show and finally being able to see all the amazing things that had been hidden from us. These pictures not only fascinated scientists but also captured the imagination of many people around the globe. It ignited a new wave of curiosity and passion for the unknown regions beyond our planetary neighborhood. In July 2015, the New Horizons mission accomplished its primary goal. The spacecraft flew past Pluto and its many moons, sending back the first detailed pictures of this celestial body to Earth. This moment in history has turned out to be an important step forward in space exploration. Astronomers obtained data about Pluto and its moons that they previously didn't have. The success of the New Horizons mission opened other avenues for NASA to explore the vast expanse of the Kuiper Belt. Recognizing the urgent need for a solid understanding of distant celestial bodies, NASA set its sights on planets situated between Neptune's orbit and nearly 50 astronomical units, AU, from the Sun. The single most striking event of the mission was definitely the close flyby with the planet Pluto and its biggest moon, Charon. Additionally, New Horizons captured clear images of Pluto's four other moons, Nix, Hydra, Kerberos, and Styx. The process of data collection took 15 months, and by October 25, 2016, the goal was achieved. The spacecraft successfully collected 6.25 gigabytes of valuable information. But what is the importance of this huge amount of information for NASA's understanding of the dwarf planet? After data collection, the findings from the New Horizons mission were so unique and distinctive that scientists had to create new high-tech data models to interpret the results. In time, it became clear that Pluto was subjected to dramatic surface and atmospheric variations, which contradicted initial expectations. Despite its reclassification as a dwarf planet, Pluto displayed a dynamic nature. It evolved at a rate that prompted NASA to reassess and revise existing knowledge about this intriguing celestial body. NASA's high-definition pictures of Pluto reveal fascinating details about this distant dwarf planet. One striking feature is Pluto's heart-shaped region, aptly named the Heart of Pluto. This geological phenomenon, scientifically termed the Sputnik planum, plays a major role in shaping many of Pluto's surface features. Surprisingly, this heart-shaped region is not warm and beating, but rather cold, icy, and almost frozen. In fact, it's a vast expanse of nitrogen ice, spanning over 1 million square miles. The presence of this enormous nitrogen glacier at Pluto's heart has significant implications. It is responsible for a process called true polar wander, which causes the planet's spin axis to shift. Before NASA's mission, scientists were unaware that Pluto's heart-shaped basin sits opposite its largest moon, Charon. This reorientation of Pluto has intriguing consequences, particularly regarding the relationship between Pluto and Charon. In simple terms, the alignment of Pluto's heart-shaped basin with the tidal axis between Pluto and Charon suggests that the heart's presence has an influence on the planet's orientation. This means that the gravitational pull between Pluto and Charon, coupled with the presence of the Sputnik planum, has caused Pluto to tilt slightly on its axis. This newfound understanding sheds light on why Pluto is such a dynamic and intriguing world, despite being uninhabitable for humans. Pluto's icy surface and the massive nitrogen glacier at its core contribute to its unique characteristics, including its tendency to tip due to the imbalance in its mass. Pluto's huge mass, coupled with the gravitational pull of its moons, can trigger a phenomenon known as true polar wander. This phenomenon occurs when a planet aligns its axis of rotation with a more favorable orbit. However, the presence of the thick ice sheet alone isn't sufficient to cause such a significant reorientation. While the massive ice glacier contributes to Pluto's mass, it is not the only factor driving the dwarf planet's tilt or the strong tidal forces experienced. In a remarkable turn of events, recent technological advancements have allowed scientists to delve deeper into Pluto's mysteries, leading to a groundbreaking discovery. Unknown to us, Pluto has a sea hidden beneath its ice skin. This is a revolutionary discovery, as it overturns our previous scientific assumptions about the planet's structure and origins. The existence of an ocean as one of Pluto's internal features radically alters our view of this distant moon, placing it among the other oceanic moons in the solar system, like Titan, Enceladus, and Europa. Although there is currently no evidence that life could exist in Pluto's ocean, the fact that it may even exist makes us question whether extraterrestrial environments could be habitable. This discovery provides grounds for the consideration of life beyond Earth and heightens the stakes for studying and finding oceanic worlds in our solar system. NASA also acknowledges that despite the absence of conclusive evidence, extraterrestrial life remains a viable hypothesis. Another relevant discovery through NASA's Cassini mission was an ocean rich in phosphorus detected below the icy surface of the Enceladus satellite orbiting around Saturn. This finding ignited continuous discussions about the possibility of extraterrestrial life, since phosphorus is vital for the formation of DNA and RNA, the constituents of the molecular basis of life. Although Enceladus remains a potential astrobiological target for space research, the complexity of assessing the habitability of Pluto takes a different turn. Pluto's case is different because, while the imaging equipment is advanced enough to take clear pictures of its surface, they are not equipped to probe into its habitability. This failure to determine the exact chemical composition of Pluto's subsurface water makes it impossible to expand our knowledge and conclusively determine if Pluto can host life. NASA continues to invest in exploring icy worlds like Pluto, but presently, the equipment for estimating the nutrients of its oceans is non-existent. However, this doesn't diminish the value of studying Pluto. The planet offers insights into various aspects of planetary science, from understanding its geological features to unraveling its origins and evolution. Each new discovery adds to our knowledge of the solar system and fuels our curiosity about the possibility of life beyond Earth. When we delve into the high-resolution images of Pluto, we uncover a multitude of hidden features, some of which may astonish you. Among these discoveries is a lake nestled within a mountain range just west of Pluto's iconic heart. Measuring approximately 20 miles wide, equivalent to about 32 kilometers, this strange body of liquid now appears frozen. However, clues scattered across the dwarf planet's surface hint at its past existence as a flowing lake brimming with a mysterious substance. The existence of a lake on Pluto is even more astonishing because it is located in the extreme cold, with temperatures of up to -230 degrees Celsius or -382 degrees Fahrenheit. Although it is unclear exactly what the liquid was made of, scientists suspect that it might have been liquid nitrogen. It is speculated that billions of years ago, liquid nitrogen may have been responsible for the carving of riverbeds and complex gullies, such as the beautiful landscape shown in the photograph. The ability of liquid nitrogen to pool and flow on a world so distant from the warmth of the sun is attributed to Pluto's fluctuating surface temperatures and pressures. As the dwarf planet orbits closer to the sun, its surface undergoes subtle warming, causing nitrogen ice to transition from solid to gas. Under specific conditions, this transition may also lead to the formation of liquid nitrogen, giving rise to these unexpected features. Pluto further displays another enigma as scientists look into its hazy atmosphere that is clearly illustrated in the images received. While Earth's atmosphere differs significantly from Pluto's, the composition of gases enveloping the distant dwarf planet adds to its allure and complexity. It offers scientists invaluable insights into planetary atmospheres and the broader dynamics of celestial bodies in our solar system. Pluto's atmosphere is incredibly thin, about 880,000 times thinner than Earth's atmosphere. It's believed to form when sunlight vaporizes surface ice, leading to a reaction with methane and other molecules. This reaction produces a complex mix of hydrocarbons, resulting in a smog-like haze. These haze particles, which scatter blue light, settle down through the atmosphere, forming intricate horizontal layers that extend to altitudes of over 120 miles or 200 kilometers. With Pluto getting farther from the Sun every 248 years, its atmosphere continues to freeze, inducing a type of snow which falls and sticks to the surface of the planet. However, the specific nature of these snow particles is still a mystery to us. Scientists are still unable to determine if the snowfalls are grainy or flake-like. There's also a possibility that this snowfall could manifest in the form of blizzard-like winds or soft snow moving around the dense, cold fog. So far, scientists have been able to observe what appears to be a layer of neon snow that condensed from the atmosphere and settled on the surface in regions like Tomal Regio. Hopefully, this will help scientists identify the kind of snowfall that rains on Pluto while investigation continues. One of the most striking features on Pluto is its snow-capped mountains in the southern hemisphere, reminiscent of the Alps on Earth when viewed from the International Space Station. However, upon closer inspection, these mountains are markedly different. They are composed of water ice, frozen as hard as granite, and covered in a type of frozen methane snow. Some of these towering peaks can reach heights of up to 2.2 miles or 3.5 kilometers above the surrounding terrain, similar to the Rocky Mountains in North America. While seeing mountains on Pluto isn't shocking, scientists are unable to explain how these mountains are formed. On Earth, the origin of mountains is essentially the result of either tectonic movements or volcanic activities. Meanwhile, the mountains on Pluto show no evidence of tectonic or volcanic activities. As such, scientists propose that its mountains are formed through a process called sublimation erosion. Sublimation erosion occurs when frozen materials like nitrogen or methane on Pluto's surface are exposed to sunlight and transformed directly into gas, leading to erosion of the surrounding terrain and leaving behind tall, spiky peaks. Remarkably, Pluto apparently regenerates its surface in some regions. Evidence suggests that a cold, slushy, lava-like substance has flowed over its landscape at various times. This unusual phenomenon is called cryovolcanism, where icy volatiles such as water, methane, and ammonia are erupted instead of lava. The same cryovolcanic activity is also seen on some other icy moons like Enceladus and Europa. The presence of mountainous regions having pits or depressions on their surfaces points to the cryovolcanic activity of Pluto. One compelling example is Right Mons, a mountain in Pluto's southern hemisphere rising 2.5 miles or 4 kilometers above its surroundings with a wide summit depression. This feature, seen in close-up images, is suspected to be an ice volcano, potentially the largest of its kind in the outer solar system. Another intriguing discovery on Pluto's surface is extensive fields of dunes resembling those found in deserts on Earth. Stretching across the western edge of its heart-shaped region, these dunes are another mystery that needs to be solved to study extraterrestrial areas where people have not yet set their footprints. The features on Pluto's surface, including its dunes, are similar to those found on Earth. The dunes on Earth are formed by the movement of wind that carries particles and deposits them in specific areas. However, the dunes on Pluto exhibit unique characteristics. They may have formed not only from wind action but also from the melting of nitrogen ice, causing sand-sized methane ice grains to be lifted by rising gases and then carried away once airborne. Moreover, Pluto's dunes are significantly larger than those on Earth, with some as tall as mountains and stretching for many miles. This is likely due to the lower gravity on Pluto, allowing particles to be transported more easily, creating these impressive features. Another intriguing aspect of Pluto's landscape is the presence of iceberg-like structures scattered across its heart-shaped region. These structures appear to be fragments of ice that have broken away from larger formations. Each fragment measures 1 to several miles wide and seems to float across the frozen surface below. Scientists believe these icebergs consist of frozen water since water ice is less dense than nitrogen ice. When they break off and are pushed into Pluto's heart, possibly through glacial flows, they are subject to the motion of the nitrogen ice below, resulting in the peculiar shapes observed in this region. The cell-like formations covering Pluto's heart also reveal information about the planet's geological processes. These formations, resembling a process called convection, occur when a fluid is unevenly warmed, whether by the sun or a boiling kettle. This convection process is believed to be a signature of Pluto's dynamic and ever-evolving surface, shedding light on the complex interplay of forces shaping this distant world. The presence of convection on Pluto suggests that something beneath its heart-shaped region is warmer than the surface. This causes the frozen nitrogen plains to slowly move through the years. By closely examining the images, scientists noticed that the icebergs tend to gather around these convection cells and are likely being pushed to the edges by the underlying forces. Scientists continue to study these formations and other characteristic features of Pluto. Hoping that soon they will have answers to the hazy questions about Pluto, each time we gaze upon Pluto, it seems to offer something new to discover. And Pluto is just one of potentially hundreds of dwarf planets in the Kuiper Belt. It's truly awe-inspiring to think about the wonders that may exist on other dwarf planets like Haumea, Makemake, or Eris, which we haven't yet had the chance to explore. Hopefully, one day in the future, we'll have the opportunity to witness their frozen beauty and unlock the secrets they hold. With the launch of the James Webb Space Telescope, we stand at the brink of a new era in space exploration. Pluto's designation as a dormant planet is quickly becoming a relic of the past as NASA unveils clear, detailed images of sophisticated geological features that have recently emerged on its surface. These stunning pictorial references mark a significant breakthrough, hinting at the dynamic nature of this distant world. It's remarkable to think that just a few gigabytes of data can unlock a world of endless possibilities for us. The wealth of information gathered by missions like New Horizons and the James Webb Space Telescope offers new glimpses into the mysteries of our universe. With each new discovery, we inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the secrets they hold. Indeed, the prospect of what lies ahead in our exploration of the cosmos is both thrilling and awe-inspiring. By far the largest planet in the solar system, Jupiter is more than twice as massive as all the other planets put together. Jupiter is the fifth planet from our Sun. The swirls and stripes of Jupiter are actually ammonia and water clouds floating in a hydrogen and helium atmosphere. Numerous moons orbit around Jupiter. Jupiter also has a number of rings, although they are much fainter and composed of dust rather than ice, unlike the well-known rings of Saturn. Jupiter has a radius that is 69,911 kilometers, 43,441 miles, which is wider than Earth. Jupiter would be roughly the size of a basketball if Earth were the size of a nickel. Jupiter is 5.2 astronomical units, AU, from the Sun, at an average distance of 484 million miles 778 million kilometers. Sunlight travels from the Sun to Jupiter at this distance in about 43 minutes. The solar system's shortest day is observed on Jupiter. The time it takes for Jupiter to rotate, or spin, once is just about 10 hours. And Jupiter completes one orbit of the Sun, a year in Jovian time, in around 12 Earth years, 4,333 Earth days. Only a 3 degrees tilt is present between its equator and its orbital path around the Sun. As a result, Jupiter has a nearly upright rotation and less dramatic seasonal variations than other planets. Jupiter resembles a tiny solar system with its several smaller moons and 4 giant moons, Io, Europa, Ganymede, and Callisto. These are Jupiter's 4 largest moons and are among our solar system's most fascinating places to visit. The solar system's most volcanically active body is Io. The largest moon in the solar system is Ganymede, even bigger than the planet Mercury. Little present surface activity is indicated by Callisto's few tiny craters. Under Europa's icy surface may lie a liquid water ocean with the necessary elements for life, making it an alluring location to study. Gravity drew spinning gas and dust to form Jupiter, a gas giant, when the rest of the solar system was forming some 4.5 billion years ago. The majority of the mass left over after the Sun formed was taken up by Jupiter, which now contains more than twice as much material as the other worlds put together in the solar system. By now, it's no news that Jupiter is a gas giant, hence, it lacks a true surface. Mostly gases and liquids are flowing around the planet. The surface of Jupiter resembles a patchwork of vibrant cloud bands and patches. The skies of the gas planet likely consist of 3 separate cloud layers that collectively measure roughly 44 miles 71 kilometers. The bright hues you see throughout Jupiter may be plumes of gases, including sulfur and phosphorus, rising from the planet's heated center. Jupiter's spots can last for a very long time since there is no solid surface to slow them down. At the equator, some of the prevailing winds on stormy Jupiter can reach speeds of up to 335 miles per hour at 539 kilometers per hour. The Great Red Spot, the largest storm in Jupiter's atmosphere, has been raging in a counterclockwise swell for more than a century and is quite well known for its intense storms. The fabled storm is so large that it may engulf the entire planet. Astronomers have just learned that the storm extends farther into space than they had previously thought. Scientists have discovered that Jupiter's storms go deep beneath its clouds and provide a clear view of the cloud interiors. Based on data from the Juno spacecraft, the greatest storm in the solar system, the Great Red Spot, is a high-pressure anticyclonic cyclone. More than 400 miles per hour is the counterclockwise rotational speed of the storm's clouds. Compared to Earth, a Category 4 hurricane's maximum wind speed is only 150 miles per hour. Imagine the destructive power the Great Red Spot possesses. In addition to that, several storms are present in Jupiter's atmosphere. In actuality, storms practically blanket the entire world on the gas giant's planet, where there is no surface and the planet's internal heat mostly influences the weather. Storms frequently linger for a long time. However, scientists have long held that Jupiter's storms are limited to the depths of the planet where sunlight can reach and where water is still able to condense. However, a recent study contradicted that. The researchers behind the new study examined the vertical structure of the Great Red Spot, as well as 2 other storms on Jupiter, using information from NASA's Juno mission. Juno has been orbiting Jupiter every 53 days since it reached Jupiter's orbit in July 2016. The spacecraft looks under Jupiter's cloud tops using a variety of onboard instruments. The storms stretch below the level at which water condenses and clouds form, according to the data from Juno's microwave radiometer, which can see hundreds of miles deep inside the planet. While some of the storms, like the Great Red Spot, reach depths of 60 miles below the cloud tops, others reach depths of almost 200 miles. However, the surrounding jets that fuel the storm travel even further into the planet's atmosphere than the Great Red Spot itself. The Great Red Spot penetrates Jupiter's atmosphere for around 500 kilometers, but the surrounding jets are located at a depth of over 3,000 kilometers. On Earth, storm development is greatly influenced by water and sunlight, but it doesn't seem to be the case on Jupiter. These roots go down deeper and pass right through the water cloud like it doesn't even matter, Scott Bolton, principal investigator of Juno from the Southwest Research Institute in San Antonio, said. And so how that works is going to require new modes and new ideas to explain. This suggests that there might be a link between the deep atmosphere of Jupiter and its interior. Why does it matter? Scientists are closely examining Jupiter since it may provide the answer to the solar system's creation tale. Its size is a key factor in being considered too. The size is one of the key reasons that it's really of high interest to us because it's so large and massive that it is thought to have formed first, Bolton said. So when we study Jupiter, we're taking a look at the very early part of the solar system. How did planets form? Where did we come from? How is our solar system made in general? The diagram of the solar system is widely recognized. The orbital trajectories of the planets around the Sun are indicated by visible circles. The truth is somewhat different because the star is so big, the gravitational center of the planets usually lies deep inside the Sun. Jupiter, however, is an enormous body in and of itself and has no connections to this solar point. Jupiter's mass is 2.5 times that of the other planets put together, just to give you an idea of how big this planet is. Instead of being inside the star, the gravitational center between the Sun and Jupiter is above it. Surprisingly, the Earth and the Sun both revolve around this center. The Sun, which is still the largest object in the solar system, is so close to this gravitational point that it almost doesn't seem to affect the star. On the other hand, Jupiter is a dwarf relative to the Sun and is also some distance from the Sun, putting it in a conspicuous orbit. On the other hand, the Great Red Spot is akin to Jupiter's storm's paternal grandfather. It has been roving for a very long time, but we've recently seen a decrease in size. Does that imply that it will eventually vanish? Jupiter appears to be a massive striped ball that spins quickly. The clouds with light-colored stripes have rising air, whereas the clouds with dark-colored stripes have sinking air on Jupiter. The contrasting pale and dark stripes are caused by winds that are moving in different directions. When this occurs, they have the ability to create large cyclones, much like how pushing and dragging a beach ball will cause it to spin. Humans have observed the Great Red Spot for at least 200 years, and it has been blowing powerful winds for practically the whole time. It can alter from day to day, just like any storm. It sometimes resembles a circle, other times an egg. Additionally, its color sometimes shifts from brownish red to pale red. It occasionally seems virtually white. But recently, researchers have found that the massive cyclone is getting smaller. The Great Red Spot was nearly 3 times bigger than it is now about 100 years ago. So why is it reducing in size? It helps to first comprehend why cyclones on Earth weaken and eventually stop to understand why it is contracting. On Earth, cyclones frequently develop over warm, deep waters before migrating to land or a colder body of water. A cyclone's winds slow down when they come into contact with solid ground, and therefore, the cyclone slows down. On Earth, cyclones are also affected by surrounding weather and winds, which can cause them to flake away in a matter of days. But unlike Earth, Jupiter doesn't have a stony, hard surface. In addition, although the air inside Jupiter's clouds is extremely cold, the air outside is extremely hot. Storms have enough energy to rampage for months or even years because of this warm air. The Great Red Spot can, therefore, actually grow a little bit taller as it does so, despite the fact that it is shrinking. It also has enough energy to continue spinning. Additionally, as it collides with nearby storms and winds, we can observe how it is flaking away at the edges. However, it is yet unclear to astronomers whether this will completely eliminate it. Some believe that it could eventually split up into numerous smaller storms. Will we ever discover the secrets of this planet and study it? What would occur if people attempted to set foot on Jupiter? Landing in a new world is the finest way to investigate it. For this reason, people have sent spacecraft to the Moon, Venus, Mars, Titan, and other places. But there are regions of the solar system that we will never fully comprehend. Jupiter is among them. Most of the gas that makes up Jupiter is hydrogen and helium, therefore, attempting to land there would be similar to attempting to do so on a cloud on Earth. On Jupiter, there is no outer crust to cushion your fall, nothing except an unending expanse of air. So the crucial query is, could you fall through Jupiter and emerge at the other end? You wouldn't even reach halfway, it turns out. This is what would happen if you attempt to land on the gas giant. First things first, there is no oxygen in Jupiter's atmosphere, therefore, be careful to pack enough air for yourself. The sweltering heat is the next issue, so make sure to bring a fan. You are now prepared to embark on an incredible quest. For scale, here's how many Earths you could stack from Jupiter's center. As you enter the top of the atmosphere, you'd be traveling at 110,000 miles per hour under the pull of Jupiter's gravity. But prepare yourself, the denser atmosphere below will hit you like a wall when you soon enter it. But it won't be enough to dissuade you. You will arrive 155 miles below the cloud tops in around 3 minutes. You will feel the full force of Jupiter's rotation here. The planet with the quickest rotation in our solar system is Jupiter. One day, as we mentioned previously, lasts roughly 10 Earth hours. This generates strong wind that can travel at speeds of more than 300 miles per hour throughout the globe. You get to the uppermost point that humans can travel to, around 75 miles below the clouds. The Galileo probe made it this far when it dove into Jupiter's atmosphere in 1995. It only lasted for 58 minutes before losing touch and then collapsing under intense pressure. Nearly 100 times as much pressure as at Earth's surface exists down here. Additionally, you won't be able to see anything, forcing you to rely solely on tools to get a sense of your environment. By 430 miles down, the pressure is 1,150 times higher. If you were in a spaceship designed like the Trees submarine, the deepest diving submarine on Earth, you might be able to survive down here. A spacecraft won't be able to survive any deeper because of the pressure and temperature. Let's assume that you might discover a means to go much lower. Some of Jupiter's greatest mysteries will be revealed by you. Sadly, you won't be able to inform anyone. You won't be able to converse since Jupiter's dense atmosphere absorbs radio transmissions, cutting you off from the outer world. Once you've reached 2,500 miles down, the temperature is 6,100 degrees Fahrenheit. The metal with the highest melting point in the universe, tungsten, can melt at temperatures that high. You will have been falling for at least 12 hours at this point. You won't even have reached the halfway point. At 13,000 miles down, you'd reach Jupiter's innermost layer. The pressure is 2 million times greater here than at the surface of the Earth. Furthermore, it is hotter than the Sun's surface. These circumstances are so severe that they alter hydrogen's composition. Everywhere around you, hydrogen molecules are squeezed so closely together that their electrons dislodge, resulting in the formation of metallic hydrogen, an uncommon material. Hydrogen in metallic form is very reflective, so it would be hard for you to use lights to look down, and it has the density of a rock. Therefore, when you descend further, gravity's downward pull is resisted by the buoyant force of the metallic hydrogen. Like a yo-yo, gravity will eventually draw you back down once that buoyancy has shot you back up. You will be stuck in mid-Jupiter, free-floating, unable to move up or down, and with no way out. When the two forces equalize, to sum things up, it would be foolish to attempt to land on Jupiter. Who knows what lies beneath those magnificent clouds? However, we may still observe and marvel at this enigmatic world from a distance until our technology becomes way more advanced. Well, that's hoping any advanced technology can even help overcome the gas giant's defenses. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.